In this lesson, we're going to talk about the Boolean data type. This will be a very short lesson because we really can't talk much about the Booleans without talking about the relational and logical operators. And I want to save that for the lessons when we start talking about if statements and decision making. So here I'm just going to introduce you to the standard Boolean types, show you how they're generated. Then we'll talk much more about how to generate Boolean data in a later chapter. So we'll open the interactive shell. And of course, the Boolean data types are true and false. Internally, true is represented as a 1, the integer 1, and false is represented as a 0. So for example, if I write an expression like this, which may or may not make sense to you, bool equals 2 is equal to 2, or more precisely, the result of comparing 2 equal to 2 is assigned to bool, will result in a value true being displayed, but internally it's really a 1, and then there's some display logic that displays the true instead of the 1. So we could turn around and say, and then display bool, and you see that now bool is false because 2 is not equal to 3. So there's really not much else to say at this point about the Boolean data type other than that there is a true value and a false value. It's generated when we make comparisons using relational operators and logical operators also. We're going to talk more about those in a later chapter. Internally, true is stored as a 1, the integer 1, and false is stored as the integer 0. I've demonstrated how to generate a Boolean value. You can also do them, of course, directly in expressions. We saw that earlier, just like so. So that's really all we're going to say about Boolean data type right now. And as I've mentioned several times already, we'll be talking a lot more about Boolean data when we get to the chapter on decision making and if statements. So we're going to wrap up this short lesson now and move on to the next lesson where we're going to go from data types to data structures and start by talking about the list data structure. In this lesson, we're going to look at the list data structure. And we're not going to talk about all the different operations you can perform on lists. We're going to save that for later in the course, but right now I just want to demonstrate how lists are made up. So we're going to use the interactive shell, so we'll open that. And the most elementary list is the empty list, which is just a set of brackets. So open and close bracket represents the empty list. If we want to actually create a list with items in it, we put items in the list, separating each item with a comma. So I've created a list called numbers that consists of the numbers 1, 2, 3, and 4. And you see I can retrieve it just like so. If I want to access a list element, I use index notation. So the first element will be in numbers sub 0, the second element will be in numbers sub 1, third element will be in numbers sub 2, and the fourth element will be in numbers sub 3, like so. And there's my sum by just adding them together. So that's a common way to retrieve each list element individually. If I want to retrieve what's called a slice, I can write 0, 2, and that will return 2 starting at the first position. Let's look at another example. So there's 3, and there's another example of pulling a slice. If we want to know how many items are in or elements are in a list, we can use the len function. We can, of course, put strings into lists. So what I'm going to do here is create a couple of lists with words in them, or actually strings. Strings is a more technical description of what's in these lists, and of course they will display just like any other list would display. If I want to combine them, I can use concatenation, and now I get a list that consists of the combination of words and words plus 1. Let's look at one more example, or actually two more examples. If I want to replicate a list, I just use the multiplication operator and the number of times I want to replicate it, and it will give me the list that many times. So there's an example of displaying the list word 5 times. Finally, you can create nested sublists. So for example, if I have a double name like this, I may want to instead make it its own list. So I can put a list inside just like so. And then when I retrieve it, it shows me that item as a list, whereas the other items will be displayed just as a string. So those are the basics of how lists in Python work. And as I said, in a later lesson or lessons, we'll spend more time performing operations on lists. What I wanted to do in this lesson was just demonstrate how lists are formed. So let's move on to another common data structure in Python, the dictionary. In this brief lesson, we're going to talk about yet another Python data structure, the dictionary. A dictionary is exactly what you think of. It's a way to look up a value based on a key, just like Webster's dictionary or any other dictionary. We're going to use the interactive shell again to demonstrate how dictionaries are created. So let's open the shell first of all. This first example will demonstrate how to create an empty dictionary, and we do that by writing an open curly brace followed by a closing curly brace. That creates an empty dictionary. But of course, that's not of much use, so let's see how to create a dictionary that actually has data in it. What we're going to do is we're going to create a little simple phone extension list. We'll call it phone list. And it's going to have an employee's name followed by their extension. So we open the dictionary with an open curly brace. We type the first key followed by a colon and then a value and then a comma. Then another key, colon, another value. And we'll do one more key and one more value, like so. And that's all there is to it. If I want to retrieve a value, I just write a key as an index. So if I type phone list Jane, it returns 233. And that's as simple as a Python dictionary is. One thing I will show you before we leave this subject is you can get a list of all the keys and all the values of a dictionary by using the keys function, which returns the keys, and the values function, which returns all the values. There's a lot more we can talk about with dictionaries, but we'll save that for later in the course when we've learned a little bit more about Python programming constructs. So we'll leave dictionaries for now and we'll move to the last data structure for the chapter, and that's the tuple.